So again, the equation we're going to be using is this: v equals f lambda. F is the frequency, lambda is the wavelength, and v is velocity, as you'd expect. Okay, so let's jump in here. Number one. A buoy on the ocean stays at stationary location. An ocean wave comes towards it. The distance between one crest and the next crest is 3 meters. The buoy moves up and down with a frequency of 0.25 hertz. And I want to know, have you drawn a picture? What's the wavelength? What's the period? And how fast is it going? So for drawing the situation here, I'm just going to draw kind of like an up and down wave. So here we go. So there's my ocean wave here. Here's my incredibly well-drawn buoy. There you go. That's what all buoys look like, I'm pretty sure. Okay. And it tells me that the distance between one crest and the next is 3 meters. So from here to here is 3 meters. And it also tells me that the frequency is 0.25 hertz. So I'm just going to write that down. There's not really a place to label that. All right, B, what's the wavelength? So wavelength, by definition, is the distance from one spot on the wave to the identical spot on the next wave. So I can look at several different places, but I'm going to look at the crest here. So wavelength is from the first spot on one wave to the next identical spot on the next wave. So we started here at the top of wave 1. We go all the way here to the top of wave 2. And that's literally what it gave me in the problem, wavelength. 3 meters. There you go. Look at that, we're already 50% done. I know. So C, what's the period? So there's several different ways that you can find period. The way you're used to doing is period is equal to the total time divided by the number of waves or the number of oscillations or whatever the case is. The problem is I don't know the time and I don't know the number of waves. It doesn't say anything about that here. It just tells me the wavelength and it tells me the frequency. Well, I remember that frequency is the number of waves over time. Number of wives over time. Yes, that's what it is. Number of wives you have divided by how long it takes you to get them. Or arrested, either way. Okay, waves divided by time. So, notice that these are opposites. Period is time over waves. Frequency is waves over time. Because they're opposites, there's another way that I can solve these. If they are opposites, then the period is equal to 1 divided by the frequency. So, the opposite of 2 is 1/2. The opposite of 4 is 1/4. So you would say 2 equals 1 over, 1 over 2, whatever the case may be. They're inverses of each other. So if I know what the frequency is, I can find the period by doing 1 divided by that frequency. Or I could do this equation here if I know the information. I don't here, but I do know, as I mentioned, I do know that the frequency is 0.25. So 1 divided by 0.25 is 4. But here's the thing. I have faith in all y'all. I have faith in y'all. I bet you can answer this without actually doing any math. Because if you think about the definition of frequency is how long it takes to make how many waves happen in 1 second. Period is how many seconds it takes to make one wave. So if I make a quarter of a wave in a second, how many seconds does it take to make a whole wave? Well, it's a quarter of a wave after 1 second, half of a wave after 2, 3/4 of a wave after 3, a whole wave after 4. You can do the same thing in the opposite direction. If I said the period was 4 seconds, you would say, okay, it's 4 seconds to make a wave. How many waves do I make in 1 second? Well, 1 second is 1/4 of 4 seconds, so the frequency should be 1/4 of a whole wave. So that's how I went about doing that one there. I just kept in mind that frequency and period have to be opposites of each other. And so this brings us to the last equation here. So this is that V equals F lambda I talked about. So V is how fast the wave is traveling. F is the frequency, which the problem said was 0.25. And lambda is the wavelength, which the problem told me was 3 when it described the motion between crest and crest. So the velocity would be 0.75 meters per second. And there you go. None of the algebra is particularly challenging on these problems. You just got to be careful. Number 2, you don't have to solve anything. You're just explaining what are some properties that basically describe waves as simple harmonic motion. So we said simple harmonic motion is motion that repeats because of a restoring force. What about waves? Why do waves also, what are some things about waves that also show that? What about waves make you think, okay, it should be simple harmonic motion? You're also doing just a description for number 3. It might be helpful to draw a picture, though. 4 and 5 are doing some calculations, some basic ones. 6 you have to be a little careful with because of this. It gives you the value in megahertz, but you're going to need to turn it into hertz. And I gave you the conversion there. So think about if you have 99.5 megahertz, how would you figure out how many individual hertz there are? So use that to try to help you out. I'll be coming around frequently to answer any questions. But what I'm going to do now is give you time to work. So we'll spend